Here we have a problem on permutation. Okay, let's go to the question. If 6 times the number of permutations of n things taken 3 at a time is equal to 7 times the number of permutations of n negative 1 things chosen 3 at a time, find n. Okay, from the given information, we have to find the value of n. Okay, now let me write the given statement as an equation. That is 6 times the number of permutations of n things are taken 3 at a time. So number of permutations means np3. That is from the given n things, we take 3 things and arrange them in a particular order. That is given by, the number of ways it can be done is given by this np3, the permutation. So this is equal to 7 times the number of permutations of n negative 1 things chosen 3 at a time. It can be written as n negative 1 p3. Okay, now in this equation we have to solve for n. Okay, for that we can consider the formula of permutation, that is npr equals to n factor divided by n negative r factorial, and many people will start using this formula. So for this npr, that means they will plug in n. So because at the place of n we have n over here, so they will plug in n for n over here. At the place of r we have 3, so they will plug in 3 for r over here, and they will try to solve the problem. But in this case, this formula is not required. Actually, the permutation formula always is not required to solve the problem on permutation when the r is given as a numerical value. In both the permutations over here, the value of r is 3. That is a numerical value. So the formula I've written over here is not required. So there is a shortcut to get the result of this np3. What is a shortcut? Let me write it. So here, since the value of r is 3, this n has to be decreased for the next 3 consecutive integers and multiply them. So I decrease this n for the next 3 consecutive integers because we have 3 over here. In case I have 4, the same n has to be decreased for the next 4 consecutive integers. Okay, now let's decrease this n for the next 3 consecutive integers. Let me take n first, then the next integer has to be n negative 1. Since we decrease, I subtract 1 from this one, I got the next consecutive integer. Again, to get the next consecutive integer, we have to subtract 1 from this one. That is n negative 1, negative 1, then we'll be getting n negative 2. Okay, here the same thing we have to do over here. That is, this n negative 1 has to be decreased for the next 3 consecutive integers, because here also the value of r is 3. Then I'm getting n negative 1. I start with the given stuff over here. To get the next consecutive integer, we have to subtract 1 from this one. Then I'm getting n negative 2. To get the next consecutive integer, I have to subtract 1 from this one. Then I'm getting n negative 3. So here, let me divide both sides by n negative 1 times n negative 2, because we find n negative 1, n negative 2 on both sides of this equation. Let me divide both sides of this equation by n negative 1 times n negative 2. Let me do it, n negative 1 times n negative 2. So this n negative 1, n negative 2 will cancel, the same thing. And here also the same thing. So on the left side we have 6 times n, that is 6n. On the right side we have 7 times n negative 3. So now we can distribute this 7 to this n and negative 3. Then I'm getting 7n. 7 times negative 3 is negative 21. Okay, now let me take the same equation over here. 6n equals to 7n, negative 21. Now let me subtract 7n from both sides. Let me do it. When I do so, this positive 7n, negative 7n will cancel out. When I combine this positive 6n and negative 7n, I am getting negative 1n or negative n. Just and then on the right side we get negative 21. Okay, I need the value of n, but here we have negative n. To get rid of this negative sign, I multiply both sides of this equation by negative 1. Let me do it. Negative 1 times negative 21. So negative times n will become positive. 1 times n is n, and here negative times n will become positive. 1 times 21 is 21. I got the value of n. The value of n is 21.